Welcome back once again to another tutorial. And last time, as I promised, I said we will be having we're going to look at using different evaluation metrics on scikit-learn function. And yeah, so let's get into let's get our hands dirty on this. So we're going to be using different evaluation metrics as scikit-learn function. For the classification we're going to be using the accuracy score. We have the precision score, the recall score, and the F1 score. And then also we're going to be trying another one using the regression function, for regression function. So we'll be using our R2 score and the mean absolute error and mean squared error. So this is just like a summary of what we've been doing. So it just basically highlights everything that we've been doing from the start to now. So it's just gonna give us a summary and a quick way of doing things. So let's get ready. Let's just dive in to this. Okay, so the first thing that we'll be doing will be importing our metrics and our ensemble, and something like a model selection. We have that's the train test split function. So let's get into that. So we'll say from scikit-learn dot metrics import. You're gonna be doing this so fast just to save on time. Score, and then precision. I believe that's the spelling of precision score, and the other one will be we say the accuracy score, precision score, and the recall score. Okay, score, and the other thing will be our F1 score. Okay, our F1 score. So this is it's a classifier. So the next thing that will be importing our ensemble, the scikit-learn dot ensemble import our random. Okay, so there's a space down here. Random forest regressor. Okay, perfect. So let's import our train test split function. Yeah, so from scikit-learn dot model selection let's import train test and a split here. Okay, perfect. So yeah, and let's set our seed like np dot let's say random, so that it ensures that we have consistent results. So let's set it as 53, something like that. So after that, the first thing will be creating our x and y function before we split our data. So let's create our x and y function, and you remember that we had our data there, which was the heart disease data, and I'll provide a link where you can download it, or if you had downloaded it before, that's still okay. So heart disease. Let me just I think I downloaded it somewhere here. So this is the housing. I leave alone this. Yeah, so looking for the heart disease, I think we downloaded it somewhere here. Let me try find it. So our heart disease, where was it? Okay. Okay, I believe it's somewhere down here. Our heart disease. Okay, so this was the housing DF. This perfect. It's here. It's here. Yeah, it's here. Perfect. So I named it as perfect. So let's just copy this and let's paste it down here. Okay, perfect. So perfect. So we had downloaded our data. That's the heart rate, and let me just test if this is running. So please accuracy score, metric, simple, recall, F1 score, accuracy score. Okay, perfect. We have our problem here. That was supposed to be a comma. Perfect. I believe that should all be well. Oh, and simple. My bad. The spelling mistake. We're all prone to mistake. And then let's delete this here. Okay, perfect. Yep, that runs well. So let's have a look at and now after we've categorized our data into X and Y. So let's split our data here down here. So our splitting our data will be X train, and then X test, and then our Y train, and our Y test. After that we have so train test split, train test and a split here. Perfect. So after that our train and what's our gonna test size gonna be? It's gonna be like 0.2. yeah. So test size is equals to 0.2. perfect. So the next thing after this is we have to create our model. Now let's create our model, and we can just give it like CLF. That's a classification model. So our classification model is gonna be, let's copy this, and let's copy this. And we know by default this comes with n estimators of 100. There's no need of us putting that, but if you want to know about that, okay, just okay, yep, you see there it comes and an estimator's default of 100, so that's okay for us. So after we've created our model, now let's feed our model. So and to feed our model, it's gonna be CLF dot feed. We're gonna be fitting our X train and our Y train, X train and our Y train. Perfect. So and after that we have to like now make predictions, and for this case I'm gonna be using we can write it this way. Let me just show you. That predict and our X test. Perfect. But for this, because we want to use the different evaluation metrics here, I'm gonna just assign this to Y parades. So perfect. So let me give it Y parades here, and there we have it. So now let's get down to now evaluating our model. So as we said above here, we had accuracy score, precision score, and the recall score and the F1 score. So for that, let's evaluate now our model. So I'm gonna be displaying this in let's say this. Let's just print it, and then you can put something like this is classification matrix, classifier matrix. Perfect. And let's close this. So let's print this. And let's call our F, and then it's gonna be accuracy. Accuracy will be our accuracy score here, and just copy it. So accuracy score Now it's gonna take our y test and our y prints. So y test and our y prints exactly. So, and we're gonna let's convert it into a percentage and 2 decimal points. So it's gonna be converting into a percentage, and a 2 decimal point will be times 100 data 2 factors to f. Perfect. And we close the data. So let me give it a percentage sign here, and let's close our function here, and perfect, we have that. So the next thing, let me just copy this, and then we'll be modifying this. So yeah, so this is gonna be accuracy, then the other one is precision score. So precision, okay, accuracy, precision. So precision score, we'll take this value here, precision score. Okay, here precision score, and let me just delete this because we don't need this. We don't need it to convert it into a percentage sign. And yep. So that's perfect. And okay, so let's do that one for recall score. Recall score will be here. This is gonna be a recall score. Recall score. Okay, that one will be our okay. So perfect. The other one will be what? F1 score. So this will be our F1 score. And so for F1 score here, F1 score. Okay, perfect. So let's run this and see. Okay, can't handle a mix of binary and so where did we go wrong here? Binary score. It has to be binary score. It's a classification. So here's the problem. It's not a regressor. It's a classifier, because when we have a look at our data, it's we are doing a classification, of 0, 1. So you have to convert here as a classifier. So classifier. So perfect. I believe that's a classifier. This is not a regressor. For regression problems, when I'm gonna be dealing with the regression problem. So I believe that's okay. So let's have a look at this. Perfect. There we have it. So we can see that our accuracy score, we have an 85%, and we have a precision score of 0.89, and a recall 0.81, and F1 score. So this is just like all summary of doing this, and in our next tutorial we're going to be seeing on how we can use a regression function here, just to determine like regression problems, and we'll be having a look at the R2 score and the mean absolute error and the mean squared error. So yeah, thank you for that.